Okay, so we just made a video and watched how we can use these ionization energy graphs and the electronegativity graphs to make predictions based on the data we are seeing to identify the trends we are seeing in the periodic table. So we use this graph to identify the trend for ionization energy. I want you to try to do the same using electronegativity. You're going to see pretty similar patterns as you use that looking at the periodic table. So once we've identified that pattern and trend, then we can start to make predictions knowing what that pattern exactly is. For ionization energy, we saw that as we go across a period on the periodic table, ionization energy is going to increase. And as we go down a group or family on the periodic table, ionization energy increases. So I'm going to move my cursor up and to the right. Ionization energy increases. Down and to the left, ionization energy decreases. Now, let's answer number 4. Number 4 is asking us to predict which element should have the lowest electronegativity. So that's going to be selenium, bromine, or krypton, and use evidence from your graph to explain how you decide. So now we need to look at electronegativity. As we can see, similar pattern. As we move across a group, as we move across a period on the periodic table, so going from lithium to fluorine, moving across a period, electronegativity increases. That means it wants to pull in electrons more. And as we go down to the next period, so that means down a group. So as we go down this way, electronegativity is going to decrease. So the 3 elements we are going to be looking at for this question are selenium, bromine, and krypton. So let's look at our periodic table and figure out where those are. So here's selenium with atomic number 34, bromine with atomic number 35, and krypton with atomic number 36. We know from our electronegativity graph right here that electronegativity is going to increase as we go across to the right on a period. So we know that electronegativity increases as we go this way. So therefore, the lowest electronegativity here is going to be the one furthest to the left, which is selenium. So in our answer, we're going to identify for number 4, hello number 4, that selenium has the lowest electronegativity. And it also asks us to use evidence from your graph to explain how you decide. And the evidence I would point to is that as we go across any group, as we go across any period, so lithium to fluorine, sodium to chlorine, electronegativity increases. So as we go across a group, electronegativity, sorry, I can't spell today, activity increases. And selenium is the furthest to the left on the periodic table of the given elements in question. Therefore, it must have the lowest electronegativity of the 3 using the identified periodic trend for electronegativity. And we know that electronegativity increases across the period because of the graph we made. So that would be your reasoning, that would be your answer. Those are questions 1 and 2. What I would say is that will, if you understand how